Chapter 8 Motion. We have studied in smaller classes that anything that is moving is said to be in motion. But this is not the actual definition of motion. Now, consider the given situation in which person A and person B are sitting in a moving bus and person C is standing at the bus stop. Consider three cases. Case 1. Person A is looking at B and finds that person B is at rest. Person B is looking at A and finds that person A is at rest. Now consider the case 2. A and B are looking at C. They feel that C is moving backwards. Case 3. C is looking at A and B. According to C, A and B are moving. This shows that the concept of motion is relative. Now let us define the term motion. The body is said to be in motion if it changes its position with respect to its surroundings in a given time. A body is said to be at rest if it does not change its position with respect to its surroundings in a given time. Consider an example. A boy named Rahul is standing in the middle of the playground. His PT teacher instructs him to move 2 meters from his initial position. Now, Rahul is confused whether to move 2 meters to the north, south, east, or west. His PT teacher helps him by saying that he has to move 2 meters to the north. So he moves 2 meters to north and fixes his final position. This example clearly shows that unless a direction is specified, you cannot fix your final position. If only magnitude is specified, like 2 meters in this example, the physical quantity we are referring to is distance. If magnitude and direction is specified, like 2 meters north in this example, the physical quantity we are referring to is called displacement. Now, let us see the differences between the two quantities. Distance is the actual path traveled by the body, whereas displacement is the shortest path between initial and final positions of the body. Now consider an example. Suppose Sita travels from position O and covers 60 meters as shown in the figure. Distance traveled by her is 60 meters and her displacement is also 60 meters. Now consider that she travels from position B to position C. Her distance is 100 meters and displacement is also 100 meters. Now she turns back and moves to B. Distance covered is 100 plus 40 equal to 140 meters and displacement is only 60 meters. Since displacement is a straight line joining initial and final positions. Consider that Sita reaches back to her initial position O. Now, distance traveled is 200 meter, but displacement is 0. This example clearly gives the difference between the two quantities. Let's now see the difference between distance and displacement. Distance is the actual path followed by the body. Displacement is the shortest path between initial and final positions of the body. Distance is a scalar quantity. A scalar quantity is a quantity which can be completely defined using its magnitude. Displacement is a vector quantity. Vector quantities are quantities which can be completely defined only if magnitude and direction is specified. Distance traveled can never be zero, but displacement can be zero if the body comes back to its initial position. Now let us solve a numerical. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Now let us see how the solution will be. Look at the diagram carefully. At the end of 2 minutes 20 seconds, that is 140 seconds, farmer has completed 3.5 rounds. 1 round in 40 seconds, 2 rounds in 80 seconds, and so on. Hence, his final position will be C if he started from A. Hence displacement equal to diagonal AC, which is equal to square root of AB square plus BC square, which is equal to square root of 10 square plus 10 square equal to square root of 100 plus 100 equal to 2 root 10 meter. Consider the data regarding the motion of two different objects A and B. In the table, the first column gives you the time, second column is the distance traveled by A in meters, third column is the distance traveled by B in meters. At 9:30 am, A has traveled 10 meters, 9:45 am, A has traveled 20 meters, 10 am, A has traveled 30 meters, 10:15 am, A has traveled 40 meters, and so on. Now, if we calculate the distance traveled by A in the first 15 minutes, the answer will be 20 minus 10 equal to 10 meter. Next 15 minutes, distance traveled by A is again 10 meters. After that, again if we calculate the distance traveled by A, it is continuously coming as 10 meter in 15 minutes. This motion is an example of uniform motion, where the body travels equal distances in equal intervals of time. Now consider the motion of B. B has travelled 12 meter at 9:30 am, 19 meter at 9:45 am, 23 meter at 10 am, and so on. Now calculate the distance travelled by B in the first 15 minutes. It is 7 meter. Distance travelled by B in the next 15 minutes is 5 meter. Distance travelled by B in the next 15 minutes is 12 meter, and so on. This shows that B has travelled unequal distances in equal intervals of time. This type of motion is called non-uniform motion. Now, let us define uniform motion and non-uniform motion. If the body covers equal distances in equal intervals of time, such a motion is called uniform motion. And if a body covers unequal distances in equal intervals of time, it is non-uniform motion.